All right, guys, so we're just going to finish up a little bit of the slideshow based on what we did with the statistics last time. So remember last time we finished before the quiz, the day before the quiz, where we were talking about mean and median, right? So we've got the median, right? That's the middle number of a set of numbers, and the mean is the average of a set of numbers, right? So we use this set right here, 8, 5, 3, 9, 6, 11, and we have another set, 8, 5, 3, 9, 6, 11, okay? And we talked about in class, right, we found the mean, right, and the median, and those are listed down here for you on the left, right? The mean was 7, and the median, I changed the number slightly to give it a, not have a fraction. So let's say the mean and median of this set is 7, right? Now remember, I added a really big number. In this case, I'll add 1,000, right? And you can notice how that really changes what the mean is, but it doesn't change the median too much. So just remember that we don't want to use the mean, or we should say the median is a better, it's better at telling us the center of the data when there's not an outlier, okay? And the number 1,000 is called an outlier, okay? So the mean can be heavily influenced by an outlier, like 1,000, or even 100 would change the mean a lot. But notice the median doesn't change so much. Even if you added another number, if you added 1,000,000 to this set on the right, notice that the median what would that go up to? Maybe 9-ish, right? Or actually 10, right? And the mean would go up a lot. So again, even if we add another 1,000,000 to this set right here, right? If we add 1,000,000, it's not going to change the median too much, but it will change the mean. So unless you have a really, a data point that's really far off from all the other ones, you can use the mean, but I would use the median if you have an outlier. So again, right, an outlier is a number that's just way far away from all the other numbers, right? So if you see the picture there, someone who, you could say someone, in common terms, right, someone that doesn't fit in, could be considered an outlier of sorts. So if we're looking at this data set, right, given the numbers 4, 5, 2, 6, 13, 7, 4, and 15, which number is the outlier? Well, I think it's a good idea to just put all the numbers in order, right? So in this data set, I would say 13 is an outlier. It's not too far away from the other values, but it's far enough away. It's 6 away from the closest value, and all the other ones are sort of in the same range, right? So I guess in some cases you could debate whether something's an outlier or not, but I would say this is it. This is. Okay, so back in the day, you also learned what a mode of a set of numbers is. So remember, the mode is the number that appears most often. And if we want to find the mode, just again put the numbers in order, pick the one that appears the most. If no number appears more than others, we say there's no mode. Also, if two numbers appear the same number of times, then you would have two modes. Okay, so there's something called multimodal distributions. There's unimodal distribution. Anyway, you don't have to worry about those sort of big terms. But in stats, right, you can have no mode, you can have one mode, or you can have more than one mode. So let's say we wanted to find the mode of all these numbers. Okay, so if you look around, you can probably figure out what it is. But I'm just going to put the numbers in order, right? So we got 1, 2, 3, 5, 6, 6, 6, 8, 9, 10, and 12. So the mode here is 6, because 6 appears the most number of times, okay? All right, last but not least is the range. So the range is just the biggest number minus the smallest number. And again, you'll want to put the numbers in order and then subtract the lowest number from the highest number. So again, if we want to find the range of this group of numbers, this is the same one we did before, right? So 1, 2, 3, 5, 6, 6, 6, 8, 9, 10, and 12. Okay. You can also check yourself by saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I have 11 numbers in the question and 11 numbers in my list. So if you want to check off, make sure you did it right. This is 11 numbers, right? And this is 11 numbers. Okay, and then the range actually does end up being 11 also, right? So we're going to take the biggest value, right, 12, and subtract the smallest one. So 12 minus 1 equals 11. That's the range. So the range of values is 11, right? So the range can just tell you, how far to go in a data, how far to go in a data set, how high it goes, minus how low it goes, So you could also do, right, if you want the max, right, we could say, what's the max of the data set? Well, the max of the data set is 12, and the minimum of the data set is 1. So, those are some other values. Obviously, you know what those words mean. So again, that's just more stuff. Now, this is very basic, what we're doing, but hopefully, if we have time, we can go deeper into this. So basically, that's all I got. I just want to give you a crash course on the rest of those terms. Okay, remember, mean is the average, median is the middle number. If you want to figure out how to get them, you can look into the slideshow. Okay? All right, so just a last comment is this weekend, also including tomorrow, so I'm going to give you a little mini project. So you can find it on Classroom. And basically what you're going to do is you're going to pick your favorite team. You're going to pick their last 20 years of wins, and you're going to find the mean, median, mode, the range, maybe any outliers. And maybe we'll throw a max and min in there also. So, but yeah, you're going to do that and have it teed up so you can see basically, a small data set and see what you can do with those. So if you don't like sports, pick the Ravens. I guess that's what I could say. Or if you have a concern and you want to do a different topic, you can just email me and we can talk about it. But anyways, hope you have a good weekend, and I'll talk to you guys later.